Welcome to Math 31. This is the second lesson on the review of linear relations. Last lesson we looked at some of the basic slope, midpoint, and distance formula questions, which is hopefully straight review. Today I'm going to be looking at the equations of linear relations. A little bit more complicated and also more important. You will be using these type of problems a lot throughout much of the course. And again, it is review. You would have seen it before frequently. So I'm going to review the two types of forms that we get for equations of linear relations. The slope y-intercept form is y is equal to mx plus b, and the m referring to the slope, as I believe you know, hopefully, and b being the y-intercept of a graph. Very useful form, and I favor this method, although many textbooks will not use it as much, but it has a lot of advantages because it contains more information. Now, what I call the standard form, but actually mean the general form, excuse me, not a big deal. This is the general form, and it looks like this: ax plus by plus c is equal to 0. So it's just set to 0, and otherwise works in a very similar way. And it's easy to go from one form to the other if you need to. So just to start off, let's sketch this line: 3x minus 2y plus 8 is equal to 0 with the grid. Now what I recommend for questions like this, and really they're relatively rare occasions you need to, I will express this in form y is equal to mx plus b, which means that I isolate the y variable. So I'm going to bring that 2y over to the other side. The algebra is pretty simple. 3x plus 8 is equal to 2y. And then divide every term by 2. So y, and I'm going to bring the y back over to the left, or just rewrite it with y on the left. This is equal to 3 over 2x plus 4. Now I'm not going to be able to do a great job of drawing this one, but not a big deal. The y, I hope it's not a big deal. The y-intercept is 4. So on the graph right there. And then the slope, m, is equal to 3 over 2. So 3 over 2 means that there's a rise of 3 and a run of 2. So that slope is maintained throughout the entire length of the line. So starting at the y-intercept, I just go up 1, 2, 3, and then from that point I go across 2, and that gives me a second point, and that's really all you need to draw this thing. Just draw straight across, and then you should be fine with this. I didn't bring my ruler today, excuse me. Anyways, we get that. Something like that at least. So nothing to it. Now more important though, or what you're going to find more common at least, is doing the reverse, is finding the equations of lines. And in order to define a line uniquely, you need two things really. You need one point on that line, and you need the slope. Because if all you have is the slope, you just have a bunch of parallel lines. But when you know one point that the line passes through, then you can define it uniquely. There's only one line that would do that. And there are two formulas that we use, or two methods really, to calculate this. The one method is called the point-slope formula. This is actually on your first formula sheet looking like this. Y minus y1 is equal to m, slope, times x minus x1. And I don't like this point-slope formula as much, although it works just fine. I prefer the slope y-intercept method, and I think overall people do. Here, what you do with that is you solve for the b value and then plug back in. I'll show you how that works very soon. So these are the two methods, and occasionally I will use the other one, or the first one, but I will favor the slope y-intercept. So if we were asked to find the equation of this line passing through these 2 points, it's passing through 4, negative 1, and then negative 2, negative 5. So down yond here. We don't have that much information to go with. We need to find the slope first off. So we find the slope. So we use the regular slope formula because we have a surplus of points, but we do not have the slope yet. So y2 minus y1 over x2 minus x1. So m is equal to negative 5 minus negative 1 is plus 1 over negative 2 minus 4. So m is therefore equal to negative 4 over negative 6. So m is equal to 2/3. So now we have what we wanted. We need now to get the use the point slope formula or the y equal mx plus b form in order to find the equation. So I will use this method. And I take one of the points. It doesn't matter which. Both are probably equally difficult. Here's my x and my y, or equally easy. I substitute in the y, negative 1, the m of 2/3, and then the x value corresponding to that point that we have is 4, and then plus b. So negative 1 is equal to 8 over 3 plus b. So b is equal to negative 1 minus 8 over 3. Now, if you're using a graphing calculator, your calculator does a great job of getting these fractions subtracted. I'm going to use this old style, which is I'm going to write them with a denominator of 3. I will multiply negative 1 by 3, giving me negative 3 minus 8. So I did that quickly, but that's getting a common denominator. And b is therefore equal to negative 11 over 3. And once you get that far with the question, it's simply a matter of taking writing the equation out again with the proper values. So therefore y, I'll write it off to the side, the equation would be equal to the slope of 2/3 minus the b value of 11 over 3. And I put the x in, of course. And there you go. That would be the equation of this line segment we've got there. Not drawn well to scale, but that's how that would work. And soon, when we start reviewing the graphing calculator, you can graph those pretty quickly and do a check on that. So that's how they work. Now the next question, the blank screen, is find the equation of the line passing through these 2 points. Now, negative 9, negative 5, I'm going to have a problem drawing this already because I see that I didn't draw the grid long enough. No big deal. I'm just going to estimate it there, and hopefully that'll work out okay. It's actually 7, 8, 9, a little far, but that's all right. It'll do for us. And then negative 9, 0 is right there. Now, what I would draw your attention to is that this is a vertical line segment. And with vertical line segments, we end up having slope undefined. So it's difficult to use any of the methods to find the slope. Now, some people will cheat, and they'll use the slope formula, and they'll get a number over 0, and then they'll still solve it, and it works. However, I'm going to use this one the more correct way, because if it's a vertical line segment, it's going to be, the equation will be a form x is equal to whatever the x value is. So in this case, x is equal to negative 9, because x is always equal to negative 9. So if you want to make a note, vertical lines are of form x equal k, where k is any real number. So x is equal to some number. Always works that way. And then similar to that, we get a vertical line, or horizontal, excuse me, horizontal lines are of form y is equal to any number k, where k is a real number. So in other words, y is equal to 2, y is equal to 3, etc. We'll be seeing a bunch more of those later on. So they're kind of trick questions. The idea is to recognize their vertical or horizontal quickly, and then you can get the equation for that. Now I'm going to bring up a new screen, and let's take a look at another problem. Find the equation of the line passing through 2, 6. So we do have our 1 point, and we want to get the line that is parallel to 2y plus x minus 4 is equal to 0. And then we're also going to want to get one that's perpendicular to 2y plus x minus 4, the same equation. Now, keeping in mind for these that we do need the same information. We need the slope and we need 1 point. Now, the 1 point is no problem. Here's your x and your y. But in order to get it for a to get parallel to 2y plus x minus 4, you need to have it in slope y-intercept form so you can identify what the slope is. So 2y is equal to, bring the x over to the other side, and it's negative x and then plus 4. Divide by 2, and you'll get negative 1 over 2 x plus 2. Now, because we're parallel to that line, we know that the slope is going to be equal. So therefore, m is equal to negative 1/2. And all we do now is use the point slope formula and sub in the given point where y is 6 and where m is negative 1/2 and x is 2 plus b. So 6 is equal to negative 1 plus b. Subtract the negative 1 away, so b is equal to negative 7. So hopefully I didn't make any mistakes on the algebra. And then our equation is just going to be, we have the slope to be negative 1/2, and then x, and now it's minus 7. And that's pretty much all you can do. So the key is to identify what the slope is. For b, it's very similar, though we have to, we already know that the slope of this line is equal to negative 1/2. But because we're perpendicular, therefore our slope m is equal to the negative reciprocal, so it's positive 2. So you flip it over and change the sign. And then we go into the slope y-intercept form. Plug in the same point, y is 6 and x is 2, and m is also 2, and solve for b. So b, 6 minus 4, b is equal to 2. So therefore y is equal to 2x, slope is 2, plus the y-intercept of 2. That's the way that works. Take a look at one more question. I think that will get us through this. Just showing you variations of these on the most books, and have other examples. But these are you can cover a lot of ground with just what you know right now. Now this one wants us to find the equation of the perpendicular bisector to A, negative 6, 2, negative 6, negative 2, right there, and B, which is 4 and 10. Now, so this is our line, basically, that is obviously running from these 2 points. And what I'm going to do, draw a rough line through them, sort of. I'll bring my ruler next class, so I'll be able to draw these better. And we want the perpendicular bisector, so that's going to be the line that's running perpendicular to it like that. Now, I'm not going to draw it in exactly, but I'm going to identify a point Q, which is the midpoint. And you see, that's what it's all about. If we want to get the equation of the perpendicular bisector, we've got to be aware that we need the point on our new line. So therefore, we get point point Q, by using the midpoint formula. And remember, with these recordings, you can stop me at any time, pause me if it's going too fast, but you should have the notes printed off so that it saves you having to draw the graphs and everything like that and write down the questions. So we add the x's together, -6 plus 4 divided by 2, and we add the y's, which is -2 plus 10 divided by 2. So -2 plus 2 is -1. I didn't do a great job of locating it, but it should work. -2 plus 10 is 8 divided by 2 is 4. So -1, 4 is about right there, and that's where the midpoint really should be. So redraw it a bit. So that's point Q, and that's our point. But the problem is we also need the slope. So we find the slope of AB, and I'm going to call another point P up there because that'll give me the new line PQ. MAB is y2 minus y1 all over x2 minus x1. So MAB is y2. So this is 10 minus -2, 10 plus 2, and then 4 minus -6 is 4 plus 6. So MAB is equal to 12 over 10, which is equal then to 6 over 5. Therefore, the slope of PQ will be equal to the negative reciprocal of that, which is -5 over 6. So you flip it over and you change the sign. Now that we've got this, we're in business because we simply have to take our given slope and our point. So I'll bring up the new screen. And we have MPQ is equal to -5 over 6. And this is through -1, 4. So y is equal to mx plus b. Sub in our values. So 4 for the y is equal to m, -5 over 6, times x is -1 plus b. So 4 is equal to 5 over 6 plus b. And get a common denominator between those two, or else use your graphing calculator. I'll do it old school for a while, over 6. So when we bring that b, isolate the b, we'll get 4 over 1 multiplied by 6 is 24 over 6, and then minus 5. So b should be equal to 19 over 6, which would mean that our equation at last is y is equal to a slope of -5 over 6 times x plus 19 over 6. Now, if you wanted to put this in the general form, you would then multiply by 6. And there's no compelling reason to do it, except that some textbooks will have it in that form. And if you multiply everything by 6, you'll get 6y is equal to negative 5x plus 19. So when you bring it all over, you'll get 5x plus 6y minus 19 is equal to 0. So that's okay too. I don't care myself, but it's whatever works. And if you were to take a look at the graph, 19 over 6 is just a bit over 3. So the y-intercept, well, I didn't do a great job of drawing it. It looks closer to 4 on mine, but if you drew this yourself with a ruler, I think you'd probably do a good job of it. So, oh, actually, no, excuse me. We have to go this one a little bit further. Yeah, so it's probably pretty close. And on your graph, I think you'll find it works pretty well. So that's the equation of the perpendicular bisector to AB. And I'm going to stop right there. And then the next review sections will be covering some other topics beyond linear. So thank you for your time. I will talk to you later.